Good evening, everybody. Welcome to today's session. Welcome to Lecturers Community Session for tonight. I'll be your host for tonight. My name is Victoria Oluwabumilare, and today's session is about networking fundamentals for IT professionals. Well, I'm really glad to be here myself. So today we have two expert speakers that will be speaking. They'll be taking us through these fundamentals and they will help us in discovering the network protocols, architectures, security, and best practices of these things today. Well, before we end the session, that's when the second speaker will come in. But for now, we'll be starting with Mr. Sunday P. Afolabi. So I'm really excited for tonight, and I hope you all are also excited because we are here to learn, even me. Nobody's island of knowledge. Please make sure that you are with your book and pen to jot down whatever you understand because before the end of today, we'll be creating a poll for all of you, a Q&A session. Mr. Afolabi,
All
are you there,
right,
sir? Please, you can speak.
all right here. Good evening. Okay, I welcome every one of you to this section. I'll be taking the first part of networking
Good
fundamental.
evening, sir.
Good evening.
You're welcome.
Thank you very much. I believe you can hear me. Okay, so now without further ado, what is networking foundation fundamentals for the IT professionals? So this section is going to be uh, covering both in the beginners, the intermediates, and advanced. So without further ado, let's get started. What you will be learning in today's section, we're going to be explaining to you what network and the internet are, which are very, very important that you know as a network engineer or network analyst. The second outline you're going to be learning also, you're going to be understanding the terms networking and network itself. So, and of course, the third outline, we have the constituent of network that has to do with the part of network. Okay, so you'll be learning types of network, network topography, network interface, division, and of course, network technicians choose Misty D. Okay, if you can hear me, can you thumbs up? Hi. Okay, good. Let's move to the next slide. If you can hear me, can you thumbs up? Hi, are we all there? Okay. Now, understanding the gulf between network and the internet. First and foremost, what is internet? You know, sometimes most people interchange or interuse the word internet for network and
Have you been
network
able to
for
clear that one up?
excuse me. Okay, yeah. So going forward, what is internet? Internet, before before we give the definitions to internet, let me clear this misconception that network is all networks are internet. Of course, no. But however, every internet is actually a network, but not every network is an what? An internet. An internet is a global connection of multiple networks. You get that? That allows external file sharing and also enable access to remote data and resources. What does that implies? Let's look at the word remote. Remote simply means a resources or data that is not reside in your own local PC or your physical uh, environment, but you are accessing it from other geopolitical place. So in order to access that one, you will make use, we set up what network connection and internet, which we use router to enable us to have access to that, like what we are doing now. You are accessing all this slide through internet. Are we together? This represents to read via the internet. You have your own network over there. I have my own network here. So what links us together is that what? The internet. So it's a global connection of multiple networks that allow external file sharing and also enable access to remote data. I believe I've done justice to that remote data or resources. Okay, so what is network itself? Network is a, are we together? Okay, thumbs up. Can I see? Can we all hear me? Can we all hear me? Okay, all right. So the network is a connection of two or more nodes, such as computers, that enable internal file, underline the word internal data or files or resources. So the internal refers to the relative data you have on your system or within the geopolitical zone where you are located. So that does not have to do with the internet. Are we together? So that particular one is called what? Network. But you accessing a global resources like such as what you are accessing today. So the internet, the network is a connection of two or more nodes such as computer. Okay. Hi, can you hear me? Okay. All right. Let's move to the next slide. Okay, so I believe we now understand what internet means and what network equally means. Okay, so having gotten that, let's proceed. Understanding the terms networking and network. System device that you can, interconnect together. So that is what we refer to as what? The node. So is the art of connecting two or more nodes together. Okay. So network, as I've earlier defined, this is an already set up connection between two or more nodes. As earlier said, of course, there are three constituents of network. There are three constituents of network. I believe you are following me. If you are there, please can you thumbs up? Okay. All right. So understanding the term, like I said, so I believe now, if before now you don't understand what networking and network are, I believe now you understand. So without further, let's get started from there, now that that has been made clear to us. So networking has three parts. For you to share data from one source to the other, there must be a connection between those entity. I mean those nodes, two or more nodes. So there must be a connection between. For you and I to communicate, I must use a language that you understand. If I'm speaking the language that you don't understand, the message that I'm trying to pass, you may not actually get it. Okay? So for you to get what I'm sending to you, the meaning, to interpret that in your own mother's tongue, it means we have to agree on a particular protocol. That protocol set of instruction, if you want to communicate me, use English language. So when I use English language, automatically you understand that, then you break it down in your own mind into your own mother's language. Okay, so there must be a protocol to be observed for nodes to communicate on the internet or on the network. So for we have a sender, we have the medium, and we have the receiver. So the sender could also mean the server, while the receiver we have that times to be what? A client. A client is an individual sending request. Then the server send back what response to you. So in that regard, the sender could serve as what? As server, and the receiver as client. Now, in between them, there is something called medium. That medium has two types. It has two types. So we have the physical medium and the wireless medium. That physical medium, you can say wired medium. And the one you cannot see the trace of connection, you can call it what? Wireless medium. E.g., like most of us now, we are using router, or most of us, we are using what, let's say, um, hotspots. We hotspot our system to join the section today. That connection, you will see that there is no wire between your laptop and the router you are using to access the internet. So however, there is what? Connection between them that enables your system to access the resources on YouTube now. Okay, so that connection is what we refer to as wireless, not physical. You can't say it. But to as many who are using Ethernet connection, are we together? Okay, are we together? All right. If you are together, can you thumbs up? Can I see your thumbs up? Can you give me high? Okay, in the chat, can you say hi? Can you say hi to me if you are hearing me clearly? Okay, all right. Now, from that place, I'm explaining the medium because we are going into the network so that we all understand the architecture of network. Okay, and also it will enable us to know and to also apply this in our day-to-day activities. Okay, um, going forward, we are explaining the network, the medium, and the receiver. So let's look at the sender and the receiver, which are the what? The computer devices. Okay, two or more devices such as computer. These computer are can serve as servers or as clients, or it can equally act as both. Okay, e.g., let me give you another instance now. Like, we have the host of today's section. So after my home presentation now, she can equally present slide from her whole hand or present something for us from our own hand. So in that regard, my own system will now serve as the receiver again. I too am receiving information from her. Okay, why now I'm serving as what? As the server disseminating information. Okay, so that is how it goes. Now, medium, there are two types or kind of medium: wired or wireless medium, which I've said earlier on. So let's look at that. So this is the packet tracer from Cisco packet tracer. So we're going to be looking at that after now. So this is the connection. If you look at the connection between the router, can you see can you see the slide? Okay, if you look at the pointer, we are pointing to the router. So we have the router here, the home router, and here we have the personal PC, that's a PC, and here we have a laptop. So now connecting, so actually this is the logical connection. Okay, even if you don't have the physical devices that you want to implement, okay, you can use your router help you do that. And of course, this can be implemented if it works fine logically. You can use that to implement your physical network. Okay, now if you look at this, we have the PC, we have the laptop, and we have the router. Now from the PC, we have a medium, wired medium, very thick line, black. Okay, so this symbolizes that the connection between this PC to this modem is what? Is wired medium, which can be seen. Okay, why, if you look at the laptop here, we have what? A dash, a black tiny lines symbolizing wireless connection. Is showing the signal, okay, that was enabled through WAP. Okay, so it just shows us that there is a connection between the router and the laptop. Okay, okay, let's proceed from that. All right, how am I communicating? Am I communicating? Am I communicating? Okay, I believe I'm communicating. And of course, if you cannot hear me clearly, please uh, let me know. Okay, all right, okay, good. Okay, now I told us earlier that the purpose of networking node or networking computer is to share resources. And for them to share resources, there must be establishment of what? Communication between two computers. You cannot just put computers and you wire both them together and expect them to communicate when there is no when either of the computer has yet to what uh, um, fulfill the protocol or follow the rules. So there won't be communication. There must be a rule that must be followed for the sharing of data and what accessing of resources to take place. So before then, communication between computers, communication between these devices on the same network, on the same, underline the word same network. So meaning that if there must be a communication between devices or computers or any system device you are using to connect with the internet or within your home, your home, there must be what establishment of communication between them. They must follow the rule that can enable them talk to each other, share data. Okay, now, so communication between these devices at the same network happens once it follows a set of rules, and this set of rules is called protocol. I know most of us we've been hearing the word protocol. I stand on the existing protocol, and on and on. So protocol in networking or network protocol, it simply means a set of rules or a set of um, regulations that must be followed for communication to take place between the system that are what in the same network. So if these rules are obeyed, there must be what communication, and the substance of this communication is called data packet. Okay, now having established the communication between devices, so what we expect is to share resources, and that resources, that data, that file, the voice you hear is referred to as data packet. Data packet. I know you've heard about that term before. They call it data packet. Why do we call it data packet? Why do we call it data packet? Okay. Why do we call it data packet? Why do we call it data packet? Okay. They call it data packet because of the other components that come alongside that follows the data that you are sharing from the server to the receiver. As you can see from the screen, you will notice that we say data packet, basic unit of information that travels from one device to another on the same network. That is very, very essential. Remember, on the same network. On the same network. This data packet has three parts, as shown below. Like I told you why we call it data packet, because you have the word data and packet. Okay, so it has the header, the body section, and the footer section. Okay, it has the header, the body, and the footer section. Don't forget, we in networking we have node and the wire or medium. Medium could be wire or wireless. Okay, so what we pass from the one node to the other is what we refer to as data packet. Okay, that passes through the medium. It passes through either wired cable or it passes through the what the signal, signal. Okay, good. So the head, what does the head encompasses or comprise of? In the head, we have the IP addresses of the sender and the receiver. Are we together? So you are sending, like, okay, if you want to send a letter to somebody now, you are writing letter to, maybe official letter to somebody who is not physically present where you are, or probably very far from. Okay, Okay, I believe you can hear me, right? Okay, good. Are we together? All right, good. Okay, okay. Are we together? Are we together? Okay, good. Okay, good. Good. So in the health section, it has the address. Now, I was using an illustration that you are writing letter to your friend, to your family member, or your friend, okay, who is not physically present, or you are writing probably application letter to an organization. So if you want to send a letter to a particular organization you have in your mind, you need to know the address of that organization. If you are passing, you're using what's it called, post office, means of passing the information. You have to address the letter envelope. You find the envelope in the letter inside the envelope, then you write the address of the company you are addressing the letter to. So having done that, you have your own address also written on it, which is what sender address and the recipient address. So the same thing applicable to the data packet. When the sender on the same network is sending, he or she is sending data from his or her system, or you're trying to access that on the processing system, there must be what? An address. And that address is called IP, which means Internet Protocol. Internet Protocol address. Okay. So each system, as we are all connected now, we all have IP addresses. Mine is different from yours, and so on and so forth. So if I want to share a particular information with a particular person on this network now, on this section, and I don't want it to be obvious, to be seen by every other person, so what do? I have to use the address of that person, the address of the person's PC. Then the message or the data goes straight to the person without being known to every other person. Okay, so are we together? I believe you can hear me. If you can hear me, can you thumbs up? Okay, okay. All right, good, good. Okay, all right. So in the body section, so the body section has the address of the person you are sending to, and your own address. You have the uh, MAC address, that's medium access control. We have that. We have protocol number. That protocol number is also known as port number. Port number. Oh, sorry. Are we together now? Okay, good, good, good. Now, from that, we have the body. The body is the one that actually carry the content of the message you are transmitting from, from one system to the other. Is the main message, the content of the message, that is the body. So it goes straight to the device, the receiving device. Why the footer? Footer help us to know that the message has finished. Help us to know that the message has finished. Okay, so from the head, so the data packet has three components: the header, the body, and the footer. The header, the ID, the IP address, the MAC address, and the protocol number. While in the middle we have the body that actually carries the information we are passing, whether encrypted or you leave it plain. So that is the body, that is the real message. Why the footer shows us that this is the end of the message. You are going to be seeing that this happen in serial, in a serial form as it enters. So when it read the last the last bit of the data packet, it it signals the receiving device that everything has been sent. Okay, so now note, if you look at that, we have a note here. The movement of the data packet over network can indicate how well the network is performing. So like we know now, sometimes when we are communicating over probably on the Zoom or wherever, you or somebody might be saying something and you are not hearing the person. It's not that the person is not speaking, probably the person has unmuted the mic and is speaking, but you are not actually hearing what the person is saying. The person is talking, but the movement of the information from that person PC to your own end is very slow. Then we will say what? We have bad network. We have bad network. That is, the information is moving, is traveling, is transmitting slowly. So it's not going the way it ought to. Then we say we have a what? A very bad connection, okay, or network. So this performance can be measured by bandwidth. I know you've heard of the word bandwidth before, but now the meaning of bandwidth means the amount of data a device receives every seconds. I repeat, bandwidth is the amount of the data, that is the data packet a device or receiving device receive every seconds. Okay, so and the bandwidth is calculated. That bandwidth is what? The measurement of what? Of the performance, of the network performance, okay. Now the bandwidth is equals to, in calculation, we have it as, you as a engineer or network administrator or network or network security, you need to know all of this because you'll be doing some calculation and all. Okay, so in order to calculate, and you've seen sometimes you see it, you say, what is the rate? Probably you are downloading something on the internet, you will see it counting in megabyte, maybe let's say 200 MB per second and all. That is the bandwidth telling you the strength or the performance of your network. Are we together? So hence the unit is, yes, I use that x as a variable, actually can be substituted for anything. So it could be, let me just change it from there. Let's say we have something like MB per BPS. You've seen something like that before, right? So you see something of this nature. Let me just change that to, so that somebody will not say y2. So the x there is the variable. Okay, so let me just give it a new color. Okay, so just a variable which could mean any value actually. Okay, so that is the bandwidth, and that's the unit. And the speed is, of course, the speed is the rate at which the data packets are received or downloaded, which very very close to the bandwidth. Okay, that's the measurement. Okay, all right. Okay, good. So having seen the data packet that passes through this medium, whether wire, cable, or the signal from one device to the other. So now let's look at the rules for these systems, or the nodes that are on the same network, uh, follow in order to communicate from one point to the other. For me to communicate to you, I'm using the language you understand. If I'm using other language that you don't understand, there won't be anything, there won't be any connection between us, there won't be any passage of what information between us. So for those systems to receive and send and use resources from one political zone to the other geopolitical zone, there must be what rules to follow. So this rule, the set of rules is called what? Protocol. I've said that earlier on. So however, in order to make it more relative to what we are talking about, which is the network, we call it network protocol, because we have a lot of protocol outside there. We have a rule in grammar, we have rule. You say I stand on existing protocol, probably you are asked to give a speech, you can use that word protocol. Everybody is using protocol. There are rules, the set rule. So in networking we call it network protocol, which is a set of rules. Okay, this is a set of rules used to govern the communication among the node, such as PC, phones, etc., connected on the same network. Everything, be putting attention to that word, same network. If you are miss those, if we have 5 people, let's say we have 5 people, and out of those 5 people we have 3 people who speak the same language, and we have the two other people there that do not understand the language. So when they are communicating and they use the language that they understand, let's say 3 of them understand, they are using to communicate, you will see other people will just be looking. They will just be looking. Even if the information that they are passing will benefit them, they will just be looking at one another, because the rule is not followed. The rule is not followed. Though they are in the same, they are together, but since their own the rule that's supposed to link all of those people together, all the 5 of them together, is not followed. The rule is that you must understand my language. Now they don't understand, they won't be able to get the information. Same to this place. When the rule, a particular system on the network does not follow the rule, there won't be something called communication, and the data will not be able to pass from one end to the other. So that's the essence. So what does the network protocol do actually? What does it do? It performs 3 basic functions. 1, communication. So communication occur when the procedure, when the protocol or the rule are observed. Then 2, for security purpose. For security purpose. For security purpose. And thirdly, for network management. These are very, very essential as an individual, as an expert, as a professional in networking. Okay, as a network engineer, network developer, or network manager, rather, network administrator, and cyber security personnel. These are very, very essential. Okay, so an individual who is looking forward to develop his career or career in cyber security, this is very, very essential. This is very, very essential. This is very, very essential. The security aspect of it, that's the network protocol security. Okay, now there are 2 models in network protocol. There are 2 models. Actually, I only put one here, but the first one, which is OSI means Organization Standard for Interchange. Okay, sorry. So the OSI, I didn't put that because that one is used as a theoretical framework. Yeah, that's the theoretical framework, but the practical framework is TCP, that has 4 layers. It has 4 layers. Why the OSI is theoretical framework for protocol, which has, or network protocol which has 7 layers. You can write it down, and you can ask question after now regarding that, or after the, if you still have time, you can ask question, or you link with me regarding that. So it has, OSI has 7 layers. You can put that down. That is the theoretical framework for network protocol. But for the practical network protocol, we have TCP. Okay, good. I believe you can hear me. If you can hear me, can you hear me? Or are you following? Are you following? Can I see you? Can I see a thumbs up? Are we together? Okay, good. All right. Let me proceed. Now, the OSI, I told you we have, there are two. Let me just put it there. Let me put it in order to, so as to avoid some ambiguity in that regard. Okay, so let me put the word yeah. Okay, let me just put OSI and TCP. Okay, TCP/IP model. Okay, so these are the framework. We have one theoretical framework, and the other one is the practical framework. Okay, so now looking at that, TCP/IP address. What is the full meaning of TCP? TCP means transmission control protocol. And IP means the internet protocol, like I said earlier on. This is the standard used to communicate over a given network. Is the standard that must be followed to communicate. If this standard is alternated, then there won't be something called communication. Okay, this helps to visualize. Are we together? This helps to visualize how data is organized and transmitted across the network. It helps to organize, like we studied the data packet initially. It has 4 body, and I told you a letter you are sending that has an envelope. The envelope is not the one that actually has the main message. The main message is inside the envelope. So when it reaches the recipient, or the receiver, or the person that the letter is intended to be sent to, the person will remove the envelope and throw it away. Okay, because the envelope has done whatsoever thing it will do. So the person will now take the letter and read. The same thing applicable here for TCP. The real message must be removed. So each layer 4, we have 4 layers. As it reaches one layer, there will be the layer that covers that data. Data is going to be removed. If it reaches the other layer, the envelope of that layer too is going to be removed. You are going to see that. Then after it reaches the 3rd layer, the last envelope will be removed. Then it will be the 4th layer too also will remove its own envelope. Then the message will reach the person. That is what we call application representation. Okay, so if you look at this here, we have the 4 layer here. We have the first layer. We have the network access layer, followed by the internet layer, and followed by the transport layer and the application layer. Now, if you look at that, the network layer has its own should I say element that wrapped the real message. Why this also has its own until it reaches the application layer. That application layer is where the real data or the real resources will be seen. I believe you are following me. Okay, I believe you are following me, right? Okay. Now, if you look at that, I equally put note under that. I say when a data packet is sent and received across a network, it is assigned a port. You know, I've told you that already. In the head, it has a port number as well. In the head section of the data frame, it has a port. Now, the address, let me give you an instance. Maybe in a school now, let's say University of Ilorin. University of Ilorin has different faculties. So if I am addressing a letter to a particular faculty in the University of Ilorin, and the address, I didn't include the name of the faculty, I only addressed the name of the school, the letter will be dropped in the school. Because it will be dropped in the school, yeah, the person will deliver it, but the school, when they receive it, they will be looking at to whom has this letter been addressed to. So the name of the faculty in this case stand as the name of the number of port. When an information is sent to my system, now it will be expecting which of the ports are you sending this message. Okay, I want to print. Let's assume I want to send or access internet. The type of protocol, the port number is 8080 or 80. Sometimes it could be 5,000, sometimes it could be 3,000. So that port, your system, your motherboard, you are sending the information reaches your motherboard. Okay, I wish we have the practical the physical action of this. Okay, now when it reaches your motherboard, your IP, it located your IP on the your IP address, and it comes to my system. So that information, that data packet, what is it doing? The instruction on what to do is also embedded in the S section as port number. So if it is 80 or I'm trying to send message, it's going to carry the port of the message port number. That it, as you can see it here. Can you see it now? For the email, let's assume is the email I'm trying to do. It's going to be what? It's going to be 25. That is email. Have you ever seen something like this before? For the developer amidst us, if you have ever seen something like this, you see 192.168.10.1, then you see something of this nature. I think you've seen something of this nature before. Let me say 8080 or 80 or whatever. So this particular port, this is a port. Anytime you see this one is IP address. From here to this place is what we call what? IP address. Okay, and of course the reason why you don't see it in Google, like Google now, if you say Google, that is www.google.com, you will see this is what we call DNS, domain name system. And why are we using that? So that the people, it will be readable. How many of us can know that Google? Okay, let me give you the Google IP address so as to see. Okay, so the DNS is used for human understanding, so that human will be able to understand, okay, this is Google. We cannot be cramming 192.0 point whatever. No, we can't be cramming that. So we need something that will be easier for the user to remember, something of this nature. For Google now, for Google, that's google.com. The IP address is this. Can you see? That's 8.8.8.8. That is their address. Okay, now nobody, is only computer that understand this. You get it faster. As soon as you press it in your browser, the browser converts it into what? Into this number that we know as what? IP address. So now let me proceed by what I'm saying. So everyone, if you are a developer here, I believe you have seen something like this. Probably when you are trying to develop React application, probably backend or front end for React, or probably you are using Laravel, or you are using Flask. So if you run Flask application, which is the backend for Python, right? So you will see something of this nature. Then you will see column and the number following it. That number following it is what we call the port. So that is telling the computer what to do and what to do when the receiver receives that. Okay. So is a port is a software based location that organizes the sending and receiving of data between devices on a network. Is so and so on and so forth. So the number gives the instruction. So why do we need the port? That is, it gives instruction. It gives instruction. It gives instructions to the receiver end. Are we together? Are we together? If you are together, can I see? Are we together? Okay, okay. All right. I believe I'm not too fast. And if there is anything you want me to re-say or re-explain, please let me know. Let me know. Okay. So now going forward, having seen, having looked at the data, packets and all, the medium, that is, we have talked about it, that we have two type of medium. It could be wired or wireless. So let's look at the physical one, wired. So I believe after now, everyone here will be able to crypt wire, will be able to crypt cable for the moderator said the proper way, the best practice on how to go about crimping um, wire. So now let's look at the wired medium. As you can see, it's a physical one. We have A, we have B. The A and B are terminal. When you buy wire in the market, let's say you buy twisted, we have different type of cable actually. We have quartz and which one again? Okay, we have twisted pairs, of course, cable. Okay, so now the first one, the former one, is actually used for antenna. I don't have the copy with me here. I've shown you. Okay, okay, all right, are we together? Okay, good. So here we have the wired medium. How creating wire medium for network kinds. Okay, there are various type of cable which are used for various purposes. So we have various cables, and each of these cables has its own purpose. That's just it. Okay, the Ethernet cables are numerical based categories. Hence we have cat5. That cat means category. The 5 is just an to to create the, to make, how am I going to put it now, differences. Yeah, the differences between those wire. We have cat 3, we have cat 4, we have cat 5, we have cat 6, 7 and 8. You will see that now. So the E, now somebody will now ask, we have cat 5, we have cat 5E. What is that E? The E mean enhanced. I know you might not have known this before, the enhanced, the E enhanced, but you've been hearing cat 5, cat 5, cat 5E, wherever. So the E there mean enhanced, and there are differences between the cat 5 and cat 5e. So meaning there are features that are added, to the previous version of cat 5. That's why the addition of what, of that E. Okay, now and etc, we have all most of them like that. We are going to see that as we progress. Now note, for every physical medium, this must be physical. Now we are not talking about wireless. We are not talking about what? Wireless. We are talking about the physical. Now for every physical medium, there are two terminals. like you can see here, we have A and we have B. Okay, we have A and we have B. There are two terminals, say A and B. So therefore, let's say terminal A is what alongside with the sender PC. Terminal B goes into the receiver PC. Okay, so now there are two terminals A and B. Therefore, there is a type of connector called RJ. And what is RJ? RJ connector means registered jack. Register jack. So we all heard of RJ5, RJ45, RJ11. RJ45 is actually used for Ethernet connection, while RJ11 is used for line phone connection. Okay, so we have that is that is expected to be fixed into the both side of the cable. So we fix the RJ here, we fix it at the other end of the cable. You are going to see that, you are going to see the steps that you need follow whenever you want to create such a wire. We are creating the wireless. So if you look at that, we have different types. Like I have said, we have cat 1, we have cat 2, we have cat 3, we have cat 4, we have cat 5, cat 5e, cat 6, cat 6a, cat 7, cat 8 and all. Okay, we have cat 8 and all. So moving forward, there are two types of twisted pairs. That's another thing we are looking at. We are looking at the cable, okay? Either cat 5, cat 6, whatsoever. We are talking about their nature now. There are two types of this twisted pair cable. So we have one called UTP and STP. What is UTP? UTP means unshielded twisted pair. Unshielded twisted pair. And we have STP, that is known as shielded twisted pair. Okay, UTP, unshielded twisted pair. What does that mean? Now this shielded has something, this networking is very broad, and what we are bringing to you now has already demystified everything about networking. From here, whosoever that have not even have no experience in that networking now has already turned out to be a professional through this section, I believe. Now, why shielded? Why shielded? Because there is a limitation to UTP. UTP as unshielded twisted pair, it does not prevent what we call crosstalk. Okay, it does not prevent such. So, and also there's something called attenuation. Attenuation, if you go deep, very deep into networking. So in order to treat, or in order to should I say eradicate or reduce such crosstalk in the cable, we now have what we call STP, which is shielded twisted pair. It's like, if you have open wire before, that cable before, you will see small brown, or or is it brown? Brown leather, or should I say leather or insulator round about those twisted pair of wire. Now let me just give you the description of the wire. The wire, this twisted pair cable has four pairs. It has four pairs in it. Each pair has two wires. Okay, it could be green and green white, yellow and orange and orange white, brown and brown white, and so on and so forth, blue and blue white. Okay, you are going to see that. Okay, so that is it. We have two types. Just put that in your mind. We have two types. We have UTP and STP. At the end point of each cable, we fix the RJ45 and on and so on and so forth. Now, in fixing connector, you can't just connect the wire to the RJ45 and you say you have connected network wire. No, you have to follow rules. You have to follow rules, okay, in doing that. That rule is called what? Color coding scheme. Okay, color coding scheme. You can't just connect red to red, white to white like we normally do in a regular electrical connection. You have your wire, if you see red and red, you have to join it together. Black and black, you join it together. That is not networking. In networking, you have to follow what we call color coding scheme. And what is that color coding scheme? We are going to see that first and foremost, the RJ45 connector has 8 pins. Of course, I've said that. Has eight pins, of course. If as it has 8 pins, so also the cable you want to fuse inside it has what? 8 wires, which is 4 pairs. Okay. Now note, there are several kinds of connectors that closely similar to RJ45. I say RJ4011 connector is used for telephone cable. Actually, it's used for telephone, and if you see it, it's very small. It's smaller in size and also narrow. It's very narrow compared to RJ45. We've seen it before. We've seen that before, I believe. Okay, most of us might not pay attention to that, but if you have a router with you, most especially anything like MTN router, if you look at the back of it, you will see a very narrow RJ47 slot there. Okay, you will see it there. It's there. Okay, now color code scheme. RJ45 connector data cable consists of 5 pairs of wire. Each consists of a solid color wire and a strip of the same color. Can you see? Now there are two wiring standard for RJ45. There are two standards for RJ45, and we are going to touch all of this. There are two standards. Am I communicating? Am I communicating? Am I communicating? Okay, good. Okay, right, good. All right, so there are two standards. One is very simple. All this one can be learned by heart, of course. You don't need to cram it, you can just know it. It's very simple. That's T568A, T568B. So these are two standards when wiring RJ45, when clipping, we call it clipping, or connecting the cable to the wire. Okay, moving forward, if you look at that, those are the standard. Let me show you the so that is the color code. Can you see it now? Can you see? Okay, I think we can. Let's look at this color code. There are 2 pins or 2 pair of wires. Now this pair of wire could either be 10 base T or 1000 base T. Ethernet uses only 2 wires pair, which are orange and green. Yes, the fact is that the RJ45 that we all know, we all see around us, most of you have used it before, you will see that there are 8 wires. That's 4 pairs of wire slotted into what? Into RJ45. That RJ45 connector that has 8 pins in it. Okay, so out of that 4 pairs, or let me say 8 wires, out of that 8 wires is only 4 wires that are actually used in Ethernet, in the internet. Okay, there are only 4 of them used. The other one are not actually, they are just there. Okay, so now look at it. Orange and green. The orange and green, if you look at it, the other 2 colors, blue and brown, are used for the phone communication or connections. I believe you can see what I'm displaying, right? Can you see it? If you can see, let me can you see it? Can you see? Hi, are we together? Okay, are we together? Okay, are we together? All right, all right. Now, if you look at that, that's the color code. Now, if you look at this, we have the T568A and T568B. T568A, if you look at the color code, we have this is the wire visually, okay? We have green, white, we have green, we have orange, and we have blue. You can see the pattern changes. The pattern here changes, okay? Now we have blue, white, we have what? Orange, then we have what? Purple, and white and purple, okay? So these are the most important one we put eyes on, okay? This green, that's 1, 2, 3, and number 6. 1, 2, 3, and number 6. Then if you look at that, the other part of it also, you will see, are we together? I believe we are together, okay? All right, now, good. Okay, we are together, correct, yeah. All right, now, looking at that, let's see the slide. I believe you can see the slide there, right? Okay, good. All right, now, you will see that this type of T568A standard and T568B standard, you will see they are different. Okay? Now, for the for T56A standard, the first color you need to, the arrangement is green, white, and white. Green, white, and green. Then orange, white, and blue follows. Okay? So arranging your wire in this form, that means you are following T568. So if you have already you've already crypted the cable inside the, are we together? If you have already crypted your wire inside the connector, RJ45 connector, the other end must be like this. You don't go and use this. You don't use orange, white. No, it's not going to work, okay? So having initiated your connections to be like this, to follow this standard, the other part, the other terminal, or the terminal B, must follow this pattern. It must be what? Green. This is type of, we call this one straight cabling, okay? This is the straight line cabling, okay? You can see green to green, white to green, white, green to green, yellow to yellow, and so on and so forth. Are we together? Now, the second form of T568A is in what we call it crossover. Okay? Crossover. When you are crossing over, the one of green, white goes to what? Goes to number 3 of green, white. Can you see the arrangement? Green, white here of the terminal A goes to the 3 of terminal B, okay? Now, if you see the second one, we have green of this one goes to the number 6. Then number 1 of this one goes to number 3. And number 2 of this one, T568A, the crossover cable, number 2 goes to number 6. Yeah, number 6, okay? Why other ones follow the same pattern? So the color, so that is how it goes. You have to follow the color scheme, okay? Without that, it will not work. It's not a normal electrical wire that we have home, okay? Now, going forward, so if you can see that again, so if you need the slide, I will make that available. So moving forward, let's go to the next. Let's see the color code as well. Most of the time, many people who are into networking, they find it difficult to creep wire successfully. Many people create wire and the wire will not even allow passage of data packet. Why? Because it's wrongly fixed, it's wrongly crypt. So if that is the case, therefore you have to do it properly for it to pass what information. Okay, so it is very very essential you understand this scheme we are talking about. Are we together? If you are together, let me see your eye. So this is the color code which makes it easy for us. So this is pin, that's it, pin 1 to 8. This pin represent what? It represents all the 8 wires of the twisted pairs, and also represent the pin of RJ45. Okay, it represents all the 5 RJ45. We are going to see that by as we progresses. Okay, excuse me. Okay, all right, now the next slide we have now, how creating a cable. Crypting a cable to RJ45 connector follows the following. You have to follow this step. Okay, follow the following step. Okay, all right, it's grammatically correct actually. All right, now crypting a cable to RJ45, the first thing you need to do, when you procure your wire at the market and you want to do maybe your home networking, you want to network your system at home, your printer and all, you want to link all together, and also the internet of things, you can link your camera, your external camera, your speaker and all. So in order to do that, you follow this procedure, and if these procedures are duly followed, yeah, you can rest assured that your wire will allow the passage of data frame. Okay, so now let's see this. I believe I'm audible enough. Okay, so now the first step you need to do, I say, having procured the wire from the market, that's twisted pair, it could either be UTP or STP. Okay, UTP means unshielded twisted pair, and why STP means what? Shielded twisted pair. Okay, now either way, either one of them, so you have to cut. You say cut plastic sheets about 1 inches from bottom cable, from both cable terminals, that is terminals A and B, not with what? The teeth. Not with teeth. You must be very careful as a network engineer. You need to buy two. You are going to see all those tools by God as we progress. So not with teeth. Engine if you want to do your wire at home, maybe electrical wire, sometimes we can use tempted to use our teeth, but in network connection, in wiring, in network wiring, you don't use teeth. Okay, you use the standard tool. Okay, so with a razor, blend in the network tool part. Okay, now look at it, 1 inches. If you look at this edge, this is a terminal of the twisted cable. Now this is a terminal and this is insulator. Can we all see it now? I believe we can see it now. From here to this place, according to the standard, it should be 1 inches. 1 inches. Okay, you remove the sheets, the plastic sheet, you remove it, you cut it in 1 inches. Okay, so having cut that away, now the step 2, unwind. You can see, why do we call it twisted pair? Because each of these pair, they are each of them is twisted. Can you see? It's twisted. Can you see? All these are twisted. So for you to, having cut that sheet 1 inches away, you have to unwind it to make it untwisted. Okay, so and you will straighten it. They say unwind and pair the similar color as seen on the previous schema, like I've shown you. So you have to arrange the color as seen initially. Before now, you are going to arrange it. can go back to the slide. Then okay, before then, this is what twisted cable, and this is what RJ45 we've been talking about. That, can you see there are 11 8 pins here, 8 pins, and these are 4 pairs, okay, and each pair has 2 wires, so it makes it 8. So 8 goes into the 8 cable. Okay, now step number 3 says straighten wires with fingers and keep it in order required. Okay, the order required, we are still referring to what we talked about here, the order of the color. So you have to make it straight. You straighten all these twisted whatever, you remove them, you make sure you unwind them and make sure that they are straight. You don't use machine for that, you use your hand. To do that. Having cut the 1 inches, having unwind it, you will now use your hand to straighten it one by one, and consider the arrangement, the color arrangement. If you are following the T568A standard, you have to arrange it according to that color. If you are arranging it in the T568B, you have to arrange it in that order. Okay, so now the step number 4 says now make a straight cut across the 8 wires with scissors to make the 1 inches as half. To make 1 inches and half. So you have to cut that 1 inches. Like now, having straightened this wire, you will now cut half of this away so that they will have equal mouth. They will be equal. No one will be taller than the other or shorter than the other. You have to cut it equally. Can you see? You cut it across, then you have that. Okay, now the step number 5, insert the 8 color wire in the RJ45 and allow the plastic sheet to properly enter the RJ connector. Can you see? So this wire now, the 8 that you have straightened very well, straight, and you have cut, and all of them have equal height, you are going to put it inside this RJ45. You put it there according to that color. You put it inside it. Then comes what we call creeper. There's something called creeper. You're going to see the image if you have not seen it before. Then lastly, insert the RJ45 connector inside the creeper and push on its ends tightly. Having pushed it, you have to clip it. You press it very well so that it can be firmly fixed. Okay, now without further, let's move to the next. Let's see the type of network we have. So the type of network we have, so we have the LAN. We've heard of the type of network before. We have WAN, we have WAN LAN, we have MAN, we have CAN, we have SAN, we have PAN, we have DAN. So those are most of them together. Okay, all right. Are we together? All right, okay. Please, if we are together, can you give me a thumbs up? Okay, good. All right, now we have seen how to creep physical medium. That's the RJ45 with the cable. Okay, now let's proceed. Network also has something called the arrangement, the geometrical arrangement. Okay, that is the term called topography. And many people have heard the word topography, network topography. What does that really mean? It simply means what? The arrangement. That's just it. The arrangement of network. That's just it. This is the geometrical arrangement of node. The node. These nodes are computer resources, communication devices. It could be system, phone, printer, and all. There are various type of network topography. We have box. That's the first one. The first thing that will come to your mind is that. So you will see how it goes. We have the ring S NT, we have fully connected NT, we have mesh NT, and we have star network topography. So in that state, let's look at the diagrammatical representation of those. So if you look at this, is a line connection in which each line, the communication passes through one node to the other, to the other, and to the other. If you look at this, the connection in electronic, they call that series connection, right? So this is a series connection, okay? So it goes, the communication, let's assume this one, can you see my cursor? Okay, good. I believe you can see my cursor, right? So if this node here, the computer, the PC here, serve as server, and you want to send something, information. So when it sends the information, it pass through that medium. Okay, it pass through that medium. So in this state, are we together? Are we together? My network. Okay, yeah, good. Okay, good. So this is what? This is star NT, this is ring NT, this is fully wired MT. All of these arrangement topographies, they each of them has its own benefits and its own what's it like called advantage and disadvantage. Okay, we have disadvantages and advantages. Okay, so disadvantages that this particular we have, like in EG, this ring and the fully connected NT. the the disadvantage of this one, the first one, that is ring NT, means that when a message is passed, is is depending on other node. So if I'm passing an information and it reaches a node, let's assume one of these node, I'm passing an information from here to all of them, right? Is broadcasting information and it will go anti-clockwise like this. It goes like this or wherever, any direction. So this is monodirectional. Okay, so when it goes like this, for this one to receive the message, it must reach this place and this particular node must pass it to this one. Let's assume this node, this very node, got crashed or something happened to it. It means the message perishes with it. Okay, it won't go further. That is the disadvantage. So then we now have this fully connected. So even if this fully connected, each node, they are what? Independent of other. Independent of other. So if one gets spoiled, it won't affect other one to receive the information. Can you see it now? So you can read more about that. Okay, so let's proceed by going to that, to the next one. We have network interface. Network interface, I want to show you that on the Cisco packet tracer. So you see this interface, the wireless interface and the wired interface. Okay, now going through that, we have network are built by adding a network interface card, NIC. I believe you've heard of that before. For your system to work with internet, for your system to be connected to other network devices, you must have what we call NIC. That's network interface card. Okay, or other network adapter or adapter to computer, and then connecting that adapters to the medium, that is wire, connecting it to the, you are going to see that. Let me just move further. So these are the devices, the enhancer, the network interface enhancer. Okay, we have hub. You've heard of that hub before. What is hub? Hub is like an extension. It's just like an extension. So let's assume you have a socket on your wall. That socket is working perfectly well, but you only have one port. Let's assume you have you have fan, you have television, you have, let's say 5 electrical gadgets, and you want to plug it on a wall socket just that has only one port. You can only plug one at a go. So for you to have access to that one port and plug all your gadget at the same time, you need to buy an extension. So what is an extension? Extension is you just plug it to make sure that the current circulates to other ports that will enhance, you to plug to other to those let out, and make all your devices to work at an instant, okay, at very very simultaneously. Not that you plug one, you remove and plug another one. No, you plug it at the same time, you now on it, depending on how. So the same thing applicable to hub. Hub is just like that. Hub receive signal from each machine from wire connection. So when you pass something from the server to other computer, the hub does not, you can't send a message to a particular uh, device. Probably you have 10 devices on the network and you want to send information. That information you are sending through hub will not send it to a particular node. It will send it to all nodes on the network. So it's only the switch. That is why the switch now comes in. So probably in the network where I want to send to I want to print, I want to send to printer. It will not broadcast on all of other devices on the network. It will go to that particular one with the IP. It goes there straight. Okay, switch does that, and that is why the definition says a device that makes connection between specific devices on a network by sending and receiving data between them. When a signal enters a port of switch, the switch look at the destination address of the frame and internally establishes a logical connection with the port connected to the destination node. Okay, good. Now the other network interface device, we have what? We have router. The router, a network device that connects multiple network together. And don't forget, I define internet initially when we started that internet, not all internet are all internet are network, but not all network are internet. Okay, now what makes network to be internet is the enhancement of that connection to access global resources. The enhancement of that network to access global resources. So what enhances that local network connection you have to the outside world data, or outside of your network data, is what? Is the router. And it works with this one too. Is very 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 interesting. So this particular router, it uses ISP. What is ISP? ISP means internet service provider. So it works with it, like e.g. like network, the network we are using, like I'm using MTN router, right? The MTN is one of the ISP that provides us with internet facility, okay, that enable me to access other resources from other from other system, from other local location. Okay, so that is ISP. So the router uses the local connection for global resources accessibility. Okay, so a network device that connects multiple network together, so that is what? Router. Okay, and if you can see it, they say it's the ability to connect the similar LAN on the same protocol. I've told you about the LAN. That's that's local area network to other network. Then that makes it what? WAN. That's wide area network. Moving forward. Yeah, the two. So if you are interested, or you've been in the field but you don't know about the two, probably, so these are tools that are very very essential for you, most especially this creeper, the creeper and the tester, then the scissors, which is very important because you will not be using your teeth to cut it. Okay, you will need the scissors. Although this creeper too has the scissors, you can use this. The end of this creeper is very sharp. It's like a scissors. That's what I normally use. So I use this when then so this we use this to cut. Then when you use this to cut, you can equally use seal your blade, the blade, this one, this yellow one, to cut it so as to remove the sheet, the plastic sheet from it, and be able to cut that one inches. So at the mouth of this clipper is what RJ45 mode. So when you put the wire into the RJ45, you now put it inside this clipper. Then you have to hold it tight. Don't forget the steps on how to clip the cable to your to RJ45. So this is the clipper they are talking about. So, and this tester, what does it do? It checks on the continuity of the flow of data, or flow of signal flow of signal in the crypted cable. So when you finish crypting your cable, the A terminal and the B terminal, you are going to fix it inside this machine. Then this machine will now show you green. If it shows green, it means it is well done. Then if it show other color, it means it does not follow what the standard. So you have to do it again. And mind you, any wrong connection you do, any wrong clipping you do, you have already you've already wasted the RJ45 like that. You cut it away, you use a new one, a fresh RJ45, because you can't fix it again. Because once crypted, you've already deformed it. So if it is not properly crypted, you will cut it away and use a new one. Okay, good. Now let's continue. We have other thing here, and probably you are giving a contrast to wired a very big structure or school, wherever, and you have done some inner. So you know we have two type of wiring. Let's say electrically now they have surface and what they call it, one name, I've forgotten that now. So yeah, surface and the one you pass through, conduit. Yeah, conduit. We have surface and we have conduit. So the same thing to networking. You can have conduit and surface. Both of them still have advantages and what disadvantages. But however, but if you are wiring it, you know you will not be able to be testing. You can't be okay, I want to use a particular wire, which one has gone to this switch, which one has gone to this up. I want to know how. So we have a tools that can help you to do that. Probably you have 3-story building and the major hub is in the first story building, and you are at the last story building, and you want to know. You can't be tracing wire and be breaking wall. You can't be breaking wall. What do? You use a tester. There's one tester here also. So this tester has two pair. You put one inside the the terminal of the wire you want to trace, and you will now be using the second one to be touching the other cable at the place you are. So when it make a sound, it means you have already identified that cable. So finally we have miscellaneous. The LAN means local area network, and of course that's that. So I want to show us something on let me show us something on the packet tracer. Let's see, before I move on. Okay, let me show us something on this. Let me see. Hi, can you see my screen? Hi, can you see my screen? Okay. Okay, I think I've moved further forward. All right, so good. let's look at, let's see how this thing works. Okay, good. All right, this is Cisco Packet Tracer software. Okay, so what's what does this software do? It actually helps us. So it helps us to visualize and also implement network connection even when we don't have the physical devices to achieve that. And one thing that interests me with this software is that any connection done logically on this software can be implemented when you have the system, when you have all the gadgets. So that is when you want to do a very gigantic maybe network connection, you can use it to implement it. And if your data are well, they are the node are well networked together, and this you check, you ping it, and you see that the connection, the packet passed, or the data packet passed, nothing missing, it means that the connection is well fixed. So you can implement it physically, and it will be it will uh, uh, it will be good, and it will work very well for you as well physically if you follow that. So it is very essential. We use that to implement connection. So now if you look at this, let me remove this and put another one. Let me remove that and put another, and show you how that connection is done, and show you NIC, that's network interface connector. Okay, um, okay, let me open my, okay, I believe you can see it there, right? Good, good. Let me remove the, good. So let me delete, let me create another one. So now this is the Cisco Packet Tracer, and it is used for to visualize networking. You can implement your networking settings out here, then physically you can implement it. So when you don't have the resources to buy all the the nodes you need maybe to complete, so Packet Tracer has, this is the interface. So the first interface we have, this one is the tab, we have the file, and so on and so forth. We have file, we have all this icon here. So this icon is to zoom, can you see, you can use it to zoom out, zoom in. Then this is to delete, probably you want to delete. You saw me when I was deleting something, so you can use this one to delete and all, this one for dragging and all. Then yeah, the third bar we have logical and physical. So if I select physical, you see the options at the right hand side changes. Okay, so meaning they depend, the what you see at the right hand side depend on what you select at the what at the left hand side. So logically, so logical connection, let's add something. So down here, this is where our the pin where we put the connection, when we add all the connection. Then down here we have hide the node, the internet devices, the network devices rather. The network devices, the first one here we have the category, which is network devices. Can you see? So having click on network devices, we now have sub network devices. So if I click on it, you can see sub category changes, right? So here also changes. So as soon as you click on what the network devices, we have this, we have router, but let's select home router, or Yeah, let's select, we've clicked on this, then let's select wireless device. So when you click on this sub the description, I believe you can see what I'm doing. So when you click on wireless devices, here also we have other information. So you can see each of these subdivided devices has its own types. Okay, so now let me click on home router and drag. You click and drag, drop it. So this home router, you can change the name from wireless router whole to whatsoever name you want it to pair. Okay, so you can just give it, let's say, WC high. So okay, good, good. I believe you can all see it, right? Good. So let's now, this is our router. This is our router, so I need to equally show you. So okay, now let's bring in device, the end device. So the end device, let's bring up PC and also a laptop. So we're going to be doing the two connection, the two medium, that's wired and wireless. So good. So let me do the connection. If you see my cursor here, the hand pointing towards this is a connection. Then can you see connections? So this connection has, the first one has different type. So you can do automatically, you can automatically choose your connection. So let me click on that automatic. Correct. So having clicked on that automatic, you can see the cursor change to like a wire. If you look at it, like a plug and wire. Okay, so what you do is to click on the router, this home router, click on it. Can you see I've clicked on it? Then drag your hand across to the PC. That green shows perfectly connected. Okay, I believe you can see what I'm doing. Are you there? Are you there? Okay, so for the, this is the wired medium, wire connection. So let's look at the
Yes, sir.
all right, okay, thank you. So let's look at the other connection, that is wireless. So for the wireless, let me equally share the screen so that you can see it here. Okay, okay, wireless. So excuse me. Okay, all right. Okay, yeah. So for the wireless, you click on the laptop, that system, you click on it. Can you see it? And if you can't see it, let me just add that to it now. Okay, excuse me seconds, let me fix this. Okay, good, 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 good. Can you see this? Can you see the good? Can you see it? All right, so now I clicked on the I
Yes, sir.
okay,
We
good.
can see.
Okay, so clicking on the laptop, we have the physical representation of the laptop. Can you see it here? So we have switch on, turn on. Can you see this option here? This, can you see where I'm pointing to? That's switch on, the power button. You switch on. Can you see the green light? Then switch off. Okay, so we want to remove this interface. You know, we talked about NIC, that for any device that must be on network, it must have an interface, network interface. That network interface could either be wired or wireless. So this one, each this system has a wired interface, NIC. Okay, so we want to remove it because we want to implement the what, wireless connection. So what do we do? First and foremost, for you to change anything in your laptop, you switch it off. Okay, that's off. Then drag it away from there, away from this side, then bring in WP, that's WPC. So put it there. Can you see it now? That is wireless connection. So let me close this. Let me close this and see what. Okay. Okay. Good, good. Are we together? Then switch on the system, the PC. Then can you see it now? Okay, good. Good. You can see that dotted line now has comes up, right? The line has come up, right? Let me stop here. So that we've exhausted all the slides. So I will make the slide available, and to further continue with this learning, I've added some link to the slide as well. So through to Cisco free camp lectures. Okay, thank you.
I'm really grateful for this session, and I really learned a lot. And I believe that everyone on this on live session too really enjoyed this session. And let me thank everyone specially. Thank everyone for joining today's session. It's really an insightful one. Yeah, networking fundamental for IT professionals is a very interesting topic, and Mr. Sunday Afolabi, P. Afolabi, has really done a great job by breaking these things down for all of us. If are those ones that have never heard of IT or networking fundamentals before in their life, with this session there to make it from let's say scratch to professional. So thank you so much, sir. And some key takeaway that I just kind of jot down. Yeah, was network protocols from today's session. It was really broad, but yeah, I won't be. I'm just summarizing though. I won't be able to touch every area. Just yeah, the networking protocols, the network architectures, the LAN, the Wi-Fi, the network topology, TCP, IP, DNS, and the likes. Then the network security. We touched on firewalls and every area, network management, even the practical parts, the ISP, internet service provider, router, connection, one. In fact, it was really a lot. And please, all of you, hope you wrote something down because me, I jotted on my own notes full. I really enjoyed the session. I jot a lot down, the height, even the abbreviations I didn't even know before, the RJ, register jack, the IP internet protocol address, and the rest, the practical layers, network, the 4 layer, the one that has 7 layers, the practical one and one. So a lot though. So well, the additional tip I want to give to everyone is that implement robust security measures to protect your network. Regularly update and patch your network devices. Monitor network performance for optimal efficiency. Then all of us should always stay up to date with industry trends and advancements. As you can see, in this networking stuff, technology is taking the world right now, and it is really, really going big. Basically, most of us cannot do anything without network, without internet. And this is what today's session is about, connecting your device and a lot of things altogether. Well, continue exploring networking concepts and technologies. Apply knowledge gained from today. Yeah, the knowledge that is gained from today, just apply the knowledge in every of our professional skills. Then I want you to also always join our sessions. There'll be another session coming up next week, but one will for feedback here in the comment section so that all of you get to fill the form. They want to know how today's session has really gone. For me, it is 10 over 10, 100 over 100. Yeah, so networking fundamentals are essential for any IT professional. Understanding this concept will help you design, implement, and manage your post and secure network. Well, Mr. Sunday said he will be giving us the slide, and I'll share with everybody who's on the group. So, Mr. Sunday, have you dropped that in my DM or in the group?
Okay, okay.
Well, I'll check that later. So I want you to fill this form, please. Well, while you're filling the form, if you have any question, don't feel shy to drop your question here now. Mr. Afolabi will answer all your questions. And if you think you have additional tips, you can just drop it there in the comment section. We'll be glad to see those things from you. That will really show that you are following.
The slide.
So I'll be dropping the form soon. Thank you, everybody. Just kindly drop your session, your questions. This is Q&A session. So it's time for questioning and answering. So that's the form in the comment section. Kindly fill the form so we're to hear from you. Anything you like us to know and how to improve our session. So, well, if there is nothing from anybody, oh, okay, okay. Thank you, Mr. Falabi. You've dropped it. Very good. Yeah, let me check now. Okay, I thought you were dropping the link to it.
Okay. Okay, let me drop
So,
that. All right.
Mr. Sunday,
All right.
can you?
Yes,
Okay,
let me drop the
thank you,
link.
sir. All right then, thank you. So that everybody will have access to the link. So for all of you that have not joined our WhatsApp forum, I'll be dropping a tech group link right now so that you'll be part of our community. So I'm about to join this group so that you stay updated. Oh, okay, Mr. Sunday, there's a question for you here.
Okay. Okay. All right.
The person said, "What is okay?" Godwin Lawal is asking, "What is the difference between OSI 7 layer and TCP?" Okay, you can see the question.
What's
Okay,
the difference
yeah.
between
If you can see the question, you can just read it out and respond.
OSI and TICP, right? Sorry. Excuse me.
Okay, I thought you were saying that though. Yes,
Yeah,
yes.
but it's not following me.
OSI 7 layers into bracket 7 layers and TCP/IP 4 layers. There
Oh,
are two questions though. That's the first one. Maybe
okay.
after you've done with that one.
Okay. Well, like I said earlier on, both of them they are network architecture, but however, OSI is theoretical framework for network. Can you hear me? I believe you can hear me, right? Okay. OSI is a theoretical framework for networking, okay? For network. Why the TCP is the practical model for network. So in school, what we do, we study the layers. That's 7 layers for OSI. OSI is a 7 layer model that comprises of data layer, the network layer, network data link layer, and representation, that's application layer, and all. But in the practical implementation of networking, we use TCP and IP model. So the difference between them is that one has 7 layers while the other one has what? 4 layers. But and also the one is theoretical, while theoretical framework, okay, while the other is the practical model framework. Are we together? I believe that is uh, clear. Hi, can you hear me?
We can hear you, sir.
I believe that.
Mr. Godwin Lawal, if you can hear, just
So,
respond. Okay, the second question is, can system on two different LANs, that's large area network,
okay.
yeah, communicate together?
Well, like I said, when you have two LAN, of course they can communicate in as much they are on the same network. They are on the same network. So LAN can be connected to another LAN, okay? LAN can be connected to the other LAN. So the end point of one LAN to the end point of the other LAN can be linked together through the use of network interface devices that we've mentioned earlier. E.g., we talk about the switch, we talk about the router. So you can have LAN linked to the other LAN and you exchange information in as much that both of them are linked together, both of them are connected together and follow the protocol, so it can be linked.
Okay, the first question, I mean, the first answer, is it clear now? Because there's another one for you, sir. The person said also, how do IPv4 differs from IPv6?
Okay, IPv4, that is the version of IP. Actually, we have two versions. So IPv4 has the limitation of the value of node that it can accommodate based on the value. And if you look at the value ranges from 0 to 255. Okay, so but IPv6 makes use of hexadecimal that makes it, to accommodate a lot of what devices. You understand? So IPv4 has limitation in the number of systems that can be accommodated on it. Are we together? Are we
Yes,
together?
sir.
So IPv4 has limitation in the number of systems that can be accommodated on it. So that is why IPv6 is what is implemented. IPv6 use what? It uses hexadecimal value. Hexadecimal value. So which is 128 bits. Are we together now? And of course, you should equally put in mind that that PV6 is actually recent version of IP address. So I believe I've done justice to that.
Yes, I said it is very clear.
Okay, thank you very much. So any other question?
Please, you all should. Yeah, there's no other question right now. Please, if you have any other question, you can drop it. So please, everybody, remember to fill the form. We want to hear from you for improvements. Thank you so much, everybody, for joining today's session. We are really grateful. We'll wait for a bit, so if there's anything before we leave the call.
So please, I'm working on that slide now. So let me drop the.
Okay, yes, the link. Thank you.
Okay.
It's on the link. Sorry, I mean the group.